My name is Prithvisha Nath and I'm the TA for this course, Engineering Mechanics. I'm a PhD student in the Department of Aerospace Engineering at IIT Madras. This is week 11 for this course, so we'll solve some questions. So this is the first question. A rear wheel driven car in motion was captured in the following image. What can be concluded about the acceleration of the car? The car has a positive acceleration along positive x direction. Next question. A 25 kg uniform bar with radius of kg equals to 2.17 meter is acted upon by two forces as shown. So you need to find out the magnitude of angular acceleration of the bar in radian per second square. So the mass of the uniform bar is 25 kg and kg is 2.17 meter. So these are the two forces which are acting on the bar, which is of 3 Newton each, and you need to find out the angular acceleration of the bar. So how can we solve the problem? Let this point be P. So we can write 0 equal to Ig alpha minus Ig alpha minus 3 into 2.6 plus 3 into 12.85. So I'll rearrange this. Ig alpha equal to minus 3 into 12.85 plus 3 into 2.6. Therefore alpha equal to 1 by Ig into 2.6. So we can write Ig as m into kg square. Kg is already given in the problem. So kg is 2.17 alpha comes out to be 0. So in the question they have asked for the magnitude of the angular acceleration. So the magnitude of zero point 26 radians per second square. Now moving on to the next part of the next question. A uniform slender link of 20 kg and kg equals to 0.58 is hinged at one end with a smooth pin as shown. A couple M equal to 10 Newton meter is applied to the link RS at S, and the link has an angular velocity of 3.5 radian per second at the instant shown. Answer the following questions based on the data given. So the bar RS has mass of 20 kg. It is hinged at one end as it can be seen from the figure at S, and kg is equal to 0.58 meter, and couple M equal 10 Newton meter is applied to the link at S, and the angular velocity of the link is 3.5 radian per second. So what we need to calculate is, first question is, what type of motion is the link undergoing? So what is the motion? As it can be seen, it is fixed at it is hinged at S. The link is hinged at S. So we can say that the motion of the link is fixed axis rotation. It can be seen from the figure, right, that it is hinged at S. So the link is undergoing fixed axis rotation. Now we are asked to find the magnitude of horizontal component of reaction force at S in newtons. So since this is a pin joint, so there are two, we can assume two forces, one in the x and the x direction and one in the y direction. So let me draw. Suppose this is ry and this is rx. So here mg is acting downwards, and here is a moment which is given in the problem. Moment is 10 Newton meter. So the couple is 10 Newton meter, and angular velocity omega is 3.5 radian per second, and the total length is 2 meters. This also has an angular acceleration, and ag will be in this direction only. Now we are asked to first find out the horizontal component of reaction force, that is this Rx. Now what can we write? Summation of F equals to m into ax. Ax is the acceleration in the x direction. So Rx equals to mr omega square, right? R will be 1 meter, and omega is already given, and m is also given. So we just need to substitute. Into 1 into 3.5 square. So Rx will be 245 Newton. So this is the horizontal force, horizontal reaction force which is acting at S. Now moving on to the next part of the problem. Determine the magnitude of vertical component of reaction force at S. Now what is the vertical component? It is nothing but Ry. We need to compute Ry. So how can we find Ry? So first we will find out the angular acceleration, and from there we will find out the Ry. So how can we find out the angular acceleration of this link? Alpha equals to nothing but ms divided by is, right? Now what is ms? M plus mg into L by 2. Is is nothing but mk square plus ml square. K is nothing but 0.58. So we'll just substitute 20 plus m is 10, right? So 10 plus mgl, m is nothing but 20 into 9.81, L is what? 2, and which is divided by 2, so it is 1. Similarly here m kg, m is nothing but 20, kg is 0.58 whole square plus 20 into 1 square. So from there I can calculate the alpha. Into 9.81 divided by 20 into 0.58 whole square plus 20. This becomes 7.715 radian per second square. Now from this I can very well find out Ag, right? Ag is nothing but alpha into r. Alpha I already calculated as 7.715 and r is nothing but 1. So this is 7.715 meter per second square. Now from this thing I can find out the magnitude of vertical component, that is Ry. Now Fy equals to m into Ay. So what is Fy? Summation of Fy. So Ry and minus m minus of mg, since it is acting in the downwards direction. This is my reference axis as shown in the problem. So mg is acting in the downward direction. So Ry minus mg equals to minus of mag. Now Ry can be written as minus mag plus mg. So this is minus 20 into Ag is nothing but 7.715 plus 20 into 9.81. So this comes out to be 41.90 Newton. So this is Ry. Now the next part of the problem, determine the magnitude of angular acceleration. So this we already calculated. So the magnitude of the angular acceleration of the link Rs in radian per second squared is, we already found it out, so that is nothing but 7.715 meter per second square. Sorry, radian per second square. Sorry. Now, moving on to the next question. A pulley of mass 50 kg and KO equal to 0.18 meter is hinged with a smooth pin as shown. A block is suspended from the pulley using a massless rope. At the instant shown, the block is released. Answer the following questions based on the data given. So this is a pulley which is hinged with a pin, and we can see that the radius of the pulley is 0.25 and mass of this block is 2 kg. It is mentioned in the figure. So what we need to find out, determine the magnitude of linear acceleration of the block in meter per second square. Determine the magnitude of angular acceleration of the pulley in radian per second square, and the magnitude of tension in the rope. So these things we need to find out. So how can we do this? So what are the given things? Mass is 50 kg. We'll just write it down. Given mass of the pulley will denote this as MP. This is 50 kg. KO is 0.18 meter. R is radius of the pulley. Let it be capital R. 0.25 meter, and MB is 2 kg. That is the mass of the block. So angular acceleration of the pulley is given by alpha equals to A by R, and also I naught is nothing but MP by K naught square, right? So we can write tension. So let me first draw. So for the pulley, tension is acting in the downwards direction, and let this be the angular acceleration. Let this be the block. Tension is acting upwards, and this is mv into g, and it's accelerating downwards. Now for the pulley we can write T into R equals to I naught into I naught alpha, right? So I'll just substitute the values. T into 0.25 equal to in place of I naught, I'll substitute MP into K naught square. So MP K naught square, and in place of alpha I will substitute A by R. So I'll further substitute these values. MP is given as 50 kg. KO is given as 0.18 meter, and A is unknown, so and R is 0.25. So from here I can write T in terms of A. So that becomes 50 into 0.18 whole square A divided by 0.25 whole square. So therefore tension equal to (25.92 A). Now this was from the pulley that we have written, and now we'll consider the block. From the block, what can we write? Taken this as my reference axis for the block. So MBG minus of tension MBG minus tension equals to MB into A, right? So I'll just substitute the values. Mass of the block is given as 2, G is 9.81. In place of tension I'll write 25.92 A equal to 2A. So this can be written as 27.92 A equal to 2 into 9.81. So from here A equal to 2 into 9.81 divided by 27.92. So A comes out to be 0.70 meter per second square. Now what is asked in the question? We are asked, yeah, the linear acceleration. So this is the linear acceleration of the block. So the linear the magnitude of linear acceleration, the magnitude of the linear acceleration of the block is 0.70 meter per second square. Now moving on to the next part of the problem. Determine the magnitude of angular acceleration of the pulley. Now angular acceleration of the pulley is nothing but A by R, right? So A we already know and R also is given in the problem. So 0.70, R is given as 0.25. So from here alpha is 2.8 radian per second square. Now moving on to the next part of the problem, magnitude of the tension in the rope. So tension is nothing but 25 0.92 into A, and we already calculated A, so tension is nothing but 0.70. So it is 18.14 Newton. So this is the tension in the rope. Now moving on to the next problem. The door of a car weighing 25 kg was accidentally left slightly open while it moved with a constant velocity. Initially, the driver then applied the brakes, leading the car to undergo a constant deacceleration of 1.75 meter per second square. So the KO of this door is given. At the instant when theta equal 30 degree, answer the following questions. So the type of motion undergone by the door is so what is the type of motion undergone by the door? It is general plane motion, right? The car door is having a constant angular acceleration when the brakes are applied. No, it's false. Now moving on to the next part of the problem. the mass moment of inertia of the car door in kg meter square about the hinge O is. So we are asked to find IO. So mass of the door is known and KO is also given in the problem. So we can easily find out the mass moment of inertia of the door, right? So IO is nothing but MO to KO square, right? So IO equal to MO is given as 25 and KO is given as 0.5. So 0.5 whole square. So this comes out to be 6.25. IO is 6.25 kg meter square. So this is IO. Now moving on to the next part of the problem. The magnitude of the angular acceleration of the door in radian per second. Angular velocity. Magnitude of angular velocity of the door in radian per second. So we will calculate this about the point O. We'll take the point O. So MO equal to Ig alpha plus this. So moment about O is 0. Ig is nothing but Ig alpha is nothing but M into K naught square minus this into alpha plus M R bar alpha R bar minus M A R. So I'll first draw this. Let this point be O, this is G, this is MA, this is nothing but M R alpha, right? And this is nothing but R bar, and this angle is given as theta. So from this diagram I can write this equation. So what do I get from this? I'll just simplify this equation. So M K naught square alpha minus M R bar square alpha plus M equal to M A R bar sine of theta. So these two cancels out, M cancels. So from here alpha becomes nothing but a r dash sine theta k naught square. So this is alpha. Now I know that omega d omega equal to alpha d theta, right? So I'll just substitute the value of alpha and write this equation as this. So finally omega comes out to be now I'll just simply substitute the given values, and from there I get omega. Omega equal to 2 into 1.75 r bar. This distance can be seen from the figure. So it's nothing but 800 minus 620, that is 180 millimeter, right? Since it is given in millimeter, I'll just convert it into meter into 1 minus, and it is asked to compute it when theta equal to 30 degree. So cos 30 divided by k naught is also given, which is equal to k naught is given as 0.5 meter. So this is 0.58 radian per second. So this is the angular velocity of the door. Now moving on to the next part of the problem. The x component of OR is nothing but the reaction force. The reaction at hinge is denoted as OR. So we need to find the x and y component of the reaction force. So OX can be written as So if I take this as my coordinate axis, okay, so they have taken it in the opposite direction. I'll take in the same way. So this is the x direction, this is the y direction. So MA minus of M R alpha sine theta minus of MR omega square cos theta. So OX is, I'll just substitute these values. M is 25, acceleration is given as 1.75, 25, R is 180, 10 to the power minus 3, alpha is, so alpha is right sine 30, then alpha is given as AR, again 1.75 R, I'll just do a square of this, and again sine theta, so square divided by K naught square, that is 0.5 square. Now the last term minus of mass is 25, (1.80) into 10 to the power minus 3 into omega we already calculated, so that is 0.58 square. Cos theta is cos of 30 degree. So therefore AX equal to So this is 41.02 meter per yeah, no, so this is reaction force. This is O. OX. So this is the reaction component in the x direction. Similarly, we need to find in the y direction, right? So OY M R omega square sine theta minus M R alpha cos theta. Yeah, so OY, I'll just substitute the values. So M is 25, R is 180 into 10 to the power minus 3, omega is nothing but 0.58 whole square sine 30 minus 25 10 to the power minus 3. First I'll write cos term, then and alpha is nothing but A, which is given as 1.75, R, so I'll do a square sine 30 divided by k naught square. K naught is 0.5. So yeah, now this is OY. So OY so this is minus of 1.6988, which implies that the direction is reversed. The y component of OR is 1.698. Negative sign just implies that the direction is reversed. So these are the questions that we discussed today. So for the first question, a rear wheel driven car in motion was captured in the following image. What can be concluded about the acceleration? We can see that it has a positive acceleration along positive x direction. Now in the next problem, the bar is 25 kg with kg given as 2.17 meter, and it is acted upon by two forces of 3 Newton each. So I'll just they have asked to calculate the angular acceleration of the bar. So angular acceleration comes out to be minus 0.26 radians per second square. So the magnitude is 0.26 radian per second square. Now next problem, here here in the next part, next question, this link RS is of mass 20 kg and kg is given as 0.58 meter, and it is hinged at one end with a smooth pin as shown. A couple M is acting at S, and the angular velocity is also given, which is equal to 3.5 radian per second. We are asked to find out what type of motion is it. We can see that it is hinged at the end S, right? So it's nothing but fixed axis rotation. And the next question is, determine the magnitude of horizontal component of reaction force as at S. So we just need to find out Rx. So summation of fx equals to m into ax. So fx is nothing but rx, and ax is r omega square. So we know all the quantities m, r and omega. So we just need to substitute. M is 20, r is 1, and omega is given as 3.5. So from there we are getting rx to be 245 Newton. Now we are asked to find out the vertical component of the reaction force. So for that we first need to compute the angular acceleration. So we will find out acceleration with this formula, that is ms equals to is into alpha. So we just substituted the values, and from there alpha comes out to be 7.715 radian per second square, and we know that ag is nothing but alpha into r. So we computed alpha and we know r is 1. So alpha ag is nothing but this quantity. And from now we can compute ry. So fy, summation of fy is what? Ry and mg. Ry is acting in the positive y direction and mg is acting downwards. So minus of mg equals to and minus mag. So from there I get ry to be 48.90 Newton. And in the next part it is asked to find the angular acceleration, which we already calculated, and that is nothing but 7.715 radian per second square. Now the next problem, a pulley of mass 50 kg, mass is given as 50, KO is nothing but 0.18 meter. It is hinged with a smooth pin, and the block is suspended from the pulley using a massless rope. So at the instant shown, the block is released. Answer the following questions based on the given data. Radius is given as 0.25, radius of the pulley, and mass of the block is given as 2 kgs. This is mass of the block. So we are asked to find out the linear acceleration of the block. So first we know that alpha equals to a by r, and also IO is nothing but mp into k naught square, right? From the pulley we can write tension into radius equals to I naught into alpha, right? And I just substitute I naught in terms of mp and k naught, and alpha as a by r. From there I can compute tension as 25.92 A. Now similarly from the block I can write mbg minus tension equals to mb into acceleration, right? So I just substitute the values. mb is nothing but 2, and in place of tension I write 25.92 into acceleration, and mb is again 2, so 2a, and from there I get a as 0.70 meter per second square. So This is what is asked in the question, that is the linear acceleration of the block. Now we need to find the angular acceleration, which is nothing but a by r, that is 2.80 radian per second square. Now they have asked the tension, and tension is already, we know the we already know tension equals to 25.92 A. So we know A, and from there we get tension as 18.14 Newton. So now the last problem is of a car. The weight of the door of a car weighing 25 kg was accidentally left slightly open while it moved with a constant velocity initially. The driver then applied the brakes, leading the car to undergo a constant deceleration of 1.75 meter per second square. KO is given, which is nothing but 0.5 at the instant when theta equal to 30 degree. Answer the following questions. So what is the type of the motion undergone by the door? It's nothing but general plane motion, right? So the next part, the car door is having a constant angular acceleration when the brakes are applied. It's not true. Now the next part of the problem, we are asked to find the mass moment of inertia of the car about the hinge O. So IO is MO into K naught square. So M is given as, MO is not, M is M is given as 25, mass of the door. So, and K naught is 0.5. From there we get I naught as 6.25 kg per meter square. Now in the next part of the problem, we are asked to find out the magnitude of the angular velocity. So we calculated moment equation about O. So from this diagram we can write this. From there we get alpha to as A r bar sin theta by K naught square. So we also know omega d omega equals to alpha d theta, integration of that. From there omega has come out to be 0.58 radian per second. Now next part of the problem, we are asked to find the x component of OR. So from this figure we can just write the components. So OX has come out to be 41.02. Similarly, for the Y component, we can write it like this, and OY is minus 1.698, which means it is in the opposite direction assumed. So this is OX, and this is OY. So this becomes negative, so it means it is acting in downward direction. So these are the questions that we solved for this week. So we will stop here.